Today I want to talk about petroleum. Petroleum is oil. And we want to talk about oil. Oil is just a fascinating subject. We use oil to power our cars and for just lots of things. We'll talk about what it's used for, etc. So let's kind of get at it. First of all, something called petroleum. What is petroleum? Well, it's also called crude oil. Okay, this is the stuff that's pumped out of the ground using one of these derricks over here. It's an oily, flammable liquid consisting of a variety of chemical compounds that is produced in sedimentary rocks of organic matter. Okay, this illustration right here, I'm going to talk some more about it a little bit later, but it talks about what a barrel of crude oil is used for. The barrel is the unit that they use to measure crude oil. I believe it's like 42 gallons. I don't know exactly, but yeah. Also involved in this is something called natural gas. It's a gas consisting mainly of methane. Methane is the element or the molecule CH4, that's carbon connected to 4 hydrogens, that is produced in sediments and sedimentary rocks during burial of organic matter. Now, one thing you're going to notice about natural gas and petroleum, there's something about sedimentary rocks, and we already learned about this. This picture right here down at the bottom is us burning natural gas. If you've got a gas stove, it burns natural gas most likely. That's the most common things. Now, where do you find petroleum and natural gas? Well, first of all, you find them in sedimentary rocks. That's right, they find it in sedimentary rocks. Now, why is that? Well, it's because if you think about it, they're organic. Petroleum is from organic things. What's that mean, organic? Now, you probably think of the organic, you think about healthy food and stuff like that. Well, in this sense, organic is basically dead things, okay? Something that died, so something that was once alive, and it died, usually plants, and those plants then eventually turned into oil and into natural gas. And so we'll talk about that process. And sedimentary rocks, of course, they get buried. So if you've got like a river or a lake or something like that, and something dies and settles to the bottom, and over time, layer after layer after layer after layer gets on top of it, then we can make some oil. Here's kind of the process of oil formation. First of all, we have, like that picture I just illustrated, we've got some decaying organic matter at the bottom of, say, a lake or something. So you've got this. This is just a common thing that we see all the time. And then the second picture is the dead matter is covered with silt and mud. This silt and mud eventually compresses into rock, leaving the organic material trapped between 2 layers of rock. So here's our decaying organic matter, and it's caught between the rock and the mud. So now we've got this decaying organic matter. It's important that there's actually no oxygen, or no O2, we would say, involved. Otherwise, it would actually just oxidize into the air. But if there's no oxygen, it can get formed. Now, notice that the layers are kind of tilted, right? This orange down here, it's tilted. Again, that's going to be caused by some variety of, probably in this case, maybe possible, some compression from plate tectonic activity. Okay, and now we have again, here's our, now it's turned into oil down here. As more silt and mud is laid down, more layers of rock are added to the top of the organic matter. Possibly some volcanic activity may also be adding extra layers of rock on top of the organic matter. This is taking millions of years. The extra weight of the rock, as well as some heating from beneath the crust of the earth, are helping to drive water out of the oil to be. You don't want any water in your oil. And so now it's even more curvy, if you will, because of that. All right. And then the oil seeps upwards through porous rocks as a result of the great pressure of the overlying layers. It does this until it hits a non-porous layer, and there it collects like so. And so basically what happens is they find these pockets, and they're always looking, the exploration geologists who are looking for oil and natural gas are looking for basically this. Now, what's this called? That's right, it's an anticline. They're looking for this anticline. When they find this anticline, what they can do is they can put a drilling rig at the top right here, and they can drill down and find the oil and the natural gas. And over here, of course, if we find some over the ocean, they have to build a drilling rig, right? Basically the same concept. It just fits over the top of over the water, because there's just a big demand for these things. Yeah, so you get that. How do you extract it? An interesting thing about how you extract it. So if you have a rig, let's say we have a water rig, you then, because you can't just sort of just, how do you pump it out of there? They actually pump something down. Usually they pump in some steam. The steam then pushes the oil up out of the ground, and then they pump it, and then they take it to wherever they're going to store it, and then they take it to wherever they're going to use it. So they actually pump something down into it. Steam is what they typically will do. In some cases, if it's really a cold place, like say, up in Alaska and stuff like that, they may have to actually put even warmer. They should get the steam super hot because they have to kind of get the stuff so it's not so cold. All right. Then once you have the oil, all right, it's actually not very usable. Oil itself is not particularly usable unless you do what we call is refine it. And the way you refine it, amazingly enough, is you take the crude oil and you boil it. That's right, you boil the oil. Now that sounds crazy because you think it would blow up and stuff like that, but it won't. We'll watch a video that'll kind of explain the process of this. It's pretty cool. So the crude oil comes out to do, and then heat it up, and then depending on its melting point, the lowest melting point stuff comes off at the top, and the next lowest melting point, kerosene, diesel, fuel oil, and then the stuff that hardly ever boils is turned into asphalt. So they actually have so many uses for the oil. It's unbelievable. We'll explain this in the video clip, I think. Now, I should say, I want to talk about this later, but oil is used for so many things. Crude oil is actually, most of it, again, half of it, let's say, is gasoline, 40% diesel fuel, heating oil, jet fuel, and kerosene. Okay, so this is, so about 90% of it is used for burning and for transportation type things, and heating oil. I don't know, all transportation heating oil, isn't it? But for burning. And then 10% for other things. Residual fuel oil. They'll do it for lots of other things. They can plastics are made out of oil. So